Problems for 2.6. Example 12. These examples illustrate that rational functions can behave in different ways near the zeros of the denominator. So basically what we're going to do is look at how the function behaves near a zero of the denominator. So let's look at letter A. In letter A, it's easier if we factor it. So we're taking the limit of x minus 2 times x minus 2 whole thing divided by x minus 2 times x plus 4. That's just the factorization of a difference between squares. So you let x approach 2. And here we have a case of a 0 over 0 situation. And what we'll do is, will we be able to cancel the factor that makes it 0? And since x is only approaching 2, we're not really letting x equal to 2 as when we evaluate the limit. So we cancel that out. And now we're really taking the limit of x minus 2 whole thing divided by x plus 4. And when we let x equal to 2 now, then that's equal to 2 minus 2 over 2 plus 4. That's just equal to 0. Now let's look at the letter B. Here we have a different situation. The top is no longer squared. So what's going to happen? What do you think? Will there still be a limit? Well, let's see. I think here we again have a 0 over 0 situation when we plug in x equal to 2. We do have a 0 over 0. So let's see if we can factor out what makes the denominator and the numerator 0. Take the limit of x minus 2 divided by x minus 2 times x plus 2. And sure enough, when we let x just approach 2, it's okay to cancel out x minus 2 both from the top and the bottom. And so we're really evaluating now the limit of 1 over x plus 2 as x approaches 2, and that's equal to 1 over 2 plus 2 equal to 1/4. So in both A and B, when we evaluate the limit where the denominator is 0, the limit does exist because we were able to factor out what causes both the numerator and the denominator to be equal to 0. This is a situation where a discontinuity occurs at x equal to 2 both in A and B, and it's a removable discontinuity because the limit exists in both cases. Now let's see what happens in letter C. And go ahead and factor again the denominator. The limit of x minus 3 whole thing divided by x plus 2 times x minus 2. We want to see how this rational function behaves as x approaches 2, but now we concentrate on the values of x that approach 2 from the right. Okay. Now notice here that we don't have a 0 over 0 situation, but indeed the denominator becomes 0. So the question now is, will it be approaching a positive infinity or a negative infinity? So what we will do is we'll concentrate on the values of x's that are close to 2 to the right of 2. So you try to plug in 2.1, 2.001, 2.0001, etc. Something that's close to 2. And what we want to do is concentrate on this difference. When you have an x minus 2 and those x's are coming from the right, that means it's greater than 2. The difference between x and 2 would be positively close to 0. So let me go ahead and just, let's just pretend that we have x equal to, say, 2.1. So 2.1 minus 3, that's a negative number. So what I'll do is put here a negative fixed number right there. And then 2.1 plus 2 is positive. Now let's then see what 2.1 minus 2 is. It's very close to 0 in a positive way. So now you've got a negative number divided by a number close to 0 in a positive sense, that means the whole ratio would go to negative infinity. Okay, now in the other side of 2, that means in letter D, we want to let x approach to coming from the left. What are values of x that are coming from the left of 2? Well, you want to plug in 1.9, 1.99, 1.999, etc. So let's see. We have now the limit of x minus 3 over, it's the same expression, x plus 2 times x minus 2. Okay, and then we let x approach 2 coming from the left. Let's see, 1.9 minus 3, that's still a negative number. 1.9 plus 2, that's still a positive number. So really the critical part here is just to find out this difference of 1.9 minus 2. That is close to 0 in the negative sense. So we'll just put a negative 0 here, just to mean that we are trying out numbers to the left of 2. And all in all, what will be the overall behavior of this ratio? You have a negative number divided by a number close to 0 in a negative way. So negative divided by a negative 0 is plus infinity. Okay, so we have seen here that in C and D, where there was a 0 in the denominator, again there's a discontinuity in all of these functions at x equal to 2. But the problem here is that the limit does not exist in C and D, so it's a non-removable discontinuity. In fact, there's more that we can say. The limit of x minus 3 divided by x squared minus 4, and then we let x approach 2. We say the limit does not exist because it's going, as you let x approach 2 from the right, it goes to minus infinity. If we let x approach 2 coming from the left, it goes to plus infinity. So the limit as x approaches 2 does not exist. Even though we're looking at infinite limits, and we know that infinity is not a number, but at least we know that the behavior of the graph would approach either plus infinity or minus infinity when it approaches a number like, say, 2 coming from the right and from the left. Okay, and that's what we have concluded from the previous slide, that because the limit of x minus 3 divided by x squared minus 4 does not exist, because the limit as x approaches 2 from the right is minus infinity, and the limit as x approaches 2 coming from the left is plus infinity. So they don't blow up at the same infinity, like whether it's plus, it should be for both sides to be positive infinity or both sides negative infinity. Now let's look at letter F. Letter F is somewhat similar. We'll just have to concentrate on how it looks like. Okay, when you see the numerator where there's a 2 minus x, another way of writing this is to factor out the negative. So really what we've got is the limit of the negative of x minus 2. Okay, so it's just reversing the sign when you pull out, and reversing the order when you pull out the negative, divided by, and of course there's a reason why I'm doing that. You want to find out as x approaches 2. Okay, so we've got an x minus 2. Now I will intentionally just pull out one factor of x minus 2 and leave the x minus 2 squared on the bottom so that we can cancel that. And really what we're looking at is the limit of 1 over the quantity x minus 2 whole thing squared as x approaches 2. And there's a negative in the front. Okay, now whether we're coming from the right or from the left of 2, we know that the difference of x minus 2 when it's squared will always be positive. So when you approach 2 coming from the right or from the left and it's squared, the difference of x minus 2 is squared, they both approach 0 in a positive way. So if you look at this, it's like you have a negative 1 over approaching 0 positively means that the limit is negative infinity. Alright, there we go. And you know we can always graph this function if you want to try. That's a good exercise. Just try to graph the function of E and F.